So, good evening, everyone. As we all know, innovation begins with curiosity, and every great journey begins with a single question. With that thought, I warmly welcome each and everyone to STOCKS Lecture 18, proudly presented by KIYE Foundation. Namaste to our respected guests, mentors, faculty members, coordinators, students, researchers, innovators, and all the passionate learners joining us from across India. Good evening, sir. I'm Mohita, one of the student coordinator. I'm your host for today's lecture. Sir, actually, we are unable to hear your voice.
Yeah. Can you hear me now? Good evening.
Yes, sir. Good evening, sir. Okay. Namaste to our respected guests. I'm Mohita, student coordinator at KIYE Foundation, and it is an absolute honor to host today's lecture 18. Before we begin, let's make the session more interactive. So kindly drop your name and college name in the chat box. Let's see how many states of India are represented today. To everyone joining us live, welcome abroad. Today, we all are connected by one mission to learn, to innovate, and to serve the nation through science and technology. About KIYE Foundation. At KIYE Foundation, we believe that classrooms build knowledge, but interaction with scientists build vision. KIYE Foundation is a non-profit organization dedicated to empowering students through innovation, leadership, aerospace, defense, space, technology, research, and career development. Our mission is to connect students with eminent scientists, researchers, industry experts, and innovators so that learning goes beyond textbooks. Every lecture, every workshop, every internship, and every interaction is another step towards creating future scientists and nation builders. STOCK stands for Space, Aerospace, and Futuristic Technologies. STOCKS is more than a lecture series. It is a journey of ideas, innovation, and inspiration. Our mission includes 52 lectures, 52 speakers, 52 topics, and 52 weeks of inspiration. So I suggest learn, connect, inspire, and grow. Today's theme is India's defense technology, missile systems, and innovation. This session actually explores advanced missile systems, mission Shakti, and the power of scientific research in national security. It inspires young minds to innovate and contribute to India's future of defense and aerospace. If you believe India will continue to lead through innovation, type Jai Hind in the chat box. Before introducing our distinguished guest speaker, let's take a quick glimpse into the vision and the journey of KIYE Foundation. I request one of our coordinators to play the AV.
and not waste it.
Thank you for such a wonderful and inspiring AV. If you found the presentation inspiring, please drop a message in the chat. And now I would like to invite our student coordinator, Ms. Rahitya, to share her journey with KIYE Foundation. Rahitya, the virtual stage is all yours.
Thank you, Mohita. Good evening, everyone. I am Rahitya, a student coordinator of KIY, and I'm glad to share my experience with the KIY Foundation today. My journey actually began right in the audience as a participant and observer. Watching the impact of what this foundation was doing, I knew I wanted to become a part of it. Soon after, I officially started as a volunteer at Vigyan Vaibhav in 2025. From there, I contributed to multiple events, gradually moving to a student coordinator. Managing events on such a massive scale has truly transformed me. Before joining KIY, I struggled deeply with stage fear and hesitation. But seeing fellow students from humble backgrounds work hard and transform themselves motivated me to step out of my comfort zone and build my own confidence. On the professional side, the growth has been equally rewarding. Collaborating with brilliant students from different backgrounds and various colleges gave me incredible real world exposure and a massive networking boost. All of the dedication directly led to a great milestone in my journey, securing an internship opportunity at DRDL. This became possible because of the invaluable guidance and belief of our mentors, Dr. G. Satish Reddy sir and Naresh Indian sir. I'm sincerely grateful to them for motivating me at every step and providing an opportunity that will lastingly impact my career. Finally, a massive thank you to the KIY Foundation team and all the amazing coordinators and volunteers. Thank you for creating a platform that does not just teach leadership but truly inspires ordinary students to achieve extraordinary things. Thank you. Jai Hind.
Thank you, Rahitya, for your wonderful words. And now comes the most awaited moment of today's session. It is my immense honor and privilege to introduce today's distinguished guest speaker, a defense scientist, visionary leader, and an esteemed alumnus of IIT Kharagpur, Dr. Shri Ummalaneni Raja Babu. He is an outstanding scientist and the Director General, Missiles and Defense Systems, DRDO. He holds a bachelor's degree in mechanical engineering from Andhra University and a master's from IIT and an MBA from JNTU. He began his career with Indian Air Force in 1988 and joined DRDO in 1995. With over 35 years of experience, he has made significant contributions to India's aerospace, aircrafts, missiles, and defense program. As program director, he played a key role in developing India's ballistic missile defense system. He was also one of the key architects of Mission Shakti, which is India's first anti-satellite missile test. As director of Research Center Imarat, he led the development of advanced missile systems and guided the weapon systems. In recognition of his remarkable achievements, he has received several prestigious awards, including the DRDO Scientist of the Year Award, Agni Award, and the Path-Breaking Research and Outstanding Technology Development Award, Vignan Pratibha Award, and the PMA Project Leader Award. We are deeply grateful to Dr. Shri Ummalaneni Raja Babu Garu, whose constant support and inspiration played a vital role in the successful conduct of Vignan Vaibhav 2K25. We look forward to his continued guidance in our future initiatives. Today, we are very privileged to hear his insights on India's defense technology, missile systems, and innovation. Please join me in welcoming Dr. Shri Ummalaneni Raja Babu Garu, and let's fill the chat with welcome, sir, and express our heartfelt gratitude for joining us today. Sir, it is a truly honor to have you with us today. We are excited to hear your thoughts, learn from your experiences, and gain knowledge. And sir, the virtual stage is all yours.
Thank you, Mohita. I hope I spelled it right. You are Mohita only, so sorry.
Yes, sir.
Yeah. In fact, first, let me thank Kalam Institute of Youth Excellence for this opportunity. It's always wonderful to interact with the students, and that's why I compliment KIYE for the stellar role played in bringing all the students together and motivating them, and then showing them the correct career path. And my association with the KIYE has been very good, and really enjoyed the association. Coming to the today's topic about defense and defense technologies, I'll try to make it as generic as possible, so that I understand the students must be from different backgrounds, and I'll not get into much technical in depth, but I'll try to cover an overall perspective, what is happening around the world, and how the defense technologies are going to change in the years to come. First, as you all know, the defense technologies continues to evolve over decades, or rather over centuries. Initially, in a primitive age, we all know that thousands of years, or maybe even much beyond that one also. The war used to be with the primitive weapons like bows and arrows. Then subsequently, as the technology evolved, then we found the rifles, and then those type of weapons. Then subsequently platforms came, be it be tanks, be it be or aircraft, or ships. But now we are in the area where even many more platforms and many dimensions of warfare is coming. But the main difference between the warfare those days and warfare today is basically the technology enablement. Earlier, the wars were fought with a person sitting in the platform. The soldiers was always, with a gun in the battlefield. The pilot was always in the aircraft, and then the submariner is in the submarine. But today, with the technology, the warfare is changing. Now we are getting into network-centric area, where the platform is, thousands of kilometers away, but the decisions and the operator is sitting, far away from where, and then giving a commands. Not only we get the information from the sensors which are remotely deployed, but based on the sensor input which is relayed over thousands of kilometers, a decision is made, and even execution of the firing command is given from far away place where the operator is not sitting. So there's a basic difference between platform centric and network centric. Till a few years back, everyone is for working only on platform centric, but now we entered an era of network centric, where all the weapons are networked, and through communication, the sensors give the information. The enablement of AI and faster computation will allow decisions to be taken faster than humans, and again execution also taking place. There's a major difference which is taking place in defense technologies nowadays. And as we see everywhere, network centric. There's a major difference. And earlier, the warfare used to be, our defense technology used to be basically centered about land, air, or probably sea. But now two more dimensions got added. Now space also has become a domain where defense technologies could play a decisive role. We are finding that many satellites are being launched, many of them military satellites, be it be for ISR role, ISR is basically for a surveillance role, or even today we have satellites for even a proactive measures, like we are even talking about weapons which will be used in the satellites in future time, and denial of service. So in addition to all the three dimensions, fourth dimension has become space. So a lot of defense technologies are working on space, and many industries, new startups also starting to work on space technologies. I think as Indian, we all should be proud. Recently, one of our startup from India, the Skyroot, has launched the first rocket into the space, and placed the satellites in the orbit. I think we are only the probably third country in the world where a private startup in a short time could successfully place satellites. But I'm not only talking about the launch vehicles, but there are n number of startups working on the satellites also. The satellites, the payloads are different. Some payloads are communication payloads, some payloads are remote sensors, some are having a higher technology like a hyperspectral or SAR payloads and all. So that way, space is offering innumerable opportunities for defense. And I think as all youngsters, you will all have a major role to play, especially from India in this segment. Other dimension is the cyber domain. Though cyber remains silent participant in the defense technologies, but the impact is quite severe. You all might have heard how some of the recent actions abroad have enabled use of cyber technologies to the maximum extent, so that before the actual military moves in through cyber technologies, they enable smooth induction of services and then winning the wars also. So these 5 dimensions are going to define the warfare in the future, and these 5 technologies will play a very, very major role. And another major difference what we are finding is earlier the defense technologies means all those big weapons, like be it be tanks or aircraft or ships or submarines and all. But nowadays you will witness a different type of a mindset in use of defense technologies, what we call the asymmetric warfare. That means in a warfare which is not symmetric. Symmetric warfare is those using those weapons which are big weapons. Asymmetric warfare are those which we use the weapons which are not conventionally used. I'm not talking about a non-conventional system. I'm saying that some weapons which are not as complex or as big as a weapons, but something like drone technologies or use of some of those technologies in some other weapons. Maybe even artificial intelligence based enable small weapons. So these asymmetric weapons will be much smaller in weight, volume, and then cost, but they'll make a big impact on the battlefield. We saw what's happening in Russia-Ukraine war. Say there, the warfare is mainly confined to drones. Every second day we hear that so and so swarm drones or so many number of drones have inflicted so and so damage to other country, and this is happening from both the sides. And we saw when Israel started, how with the help of pages they took out many of the Hamas warriors remotely through technologies. And we also now see what's happening in Iran and then USA-Israel war also. This asymmetric warfare is gaining a momentum. Small weapons, low-cost weapons like drones. In fact, you all would have read in newspapers that a drone costing $20,000 is able to take out a complex weapon system of probably $5 to $10 million. So that is the type of ratio the asymmetric warfare is gaining in warfare. It's all technology enabled, and if you see, actually basically nothing but other than innovative use of existing technologies. That's why I wanted to use the word innovation. Innovation is the key. In defense technologies are everywhere. Today you all are seeing worldwide, where a small idea, an innovative idea can change life. Innovative idea can make a big difference the way the technology is applied. And many startups are able to use innovation, and then maybe they all become big companies. So my request to all of you is please have innovative thinking. Let the creativity in you be alive and start thinking differently. Some of the innovative ideas may appear that they are not practical, but one of the ideas that clicks, that is going to make a big difference. Another difference is innovator will become a leader, others will become follower. If you don't innovate, we have to just be a follower, and then someone who innovates, we have to tag their probably path and then get the technology. So innovation is very easy, very important and key for defense technologies. And as it is in defense, surprise is the biggest element, and innovation brings in the surprise. But innovation alone cannot bring it, but we need to have the infrastructure, knowledge base, and then enablement of all these technologies in the country. Today, if you see the trend of the technologies, earlier we used to have weapons which are much bigger in size. Today, we have weapons which are a small fraction of that weight, but more effective. And if you talk about a computational power, computers we are seeing, there is a saying that, I think every 6 years or 10 years, the computation becomes, 10 times and the size becomes 1/10 of the size. That's the type of, change that comes in avionics. So especially when you talk about weapon systems, the payload, importance of the payload. The type of energy we spend to take the payload to a certain distance and orbit and all is significant. So if you're able to miniaturize, then we'll get much productivity out of the same system. So miniaturization is very key. But miniaturization, it requires a lot of technologies, and it is not simple and then easy to miniaturize. You all are aware of the semiconductors and all. Earlier people used to think that okay, like much bigger things, microprocessors and all. Then someone talked about in 28 nanometers. Today people are talking about probably 3-4 nanometers type of chips and all. And even though they are miniaturized, but they bring in a lot of power, so that the functionality wise they can be more efficient than earlier ones. And the miniaturization not only for computer chips, I am talking about miniaturization in power systems, miniaturization in drives, and miniaturization in every system that is being used in defense technologies. And as we bring in artificial intelligence into the defense systems, earlier all the decisions were taken by humans, whether to fire, not to fire, whether to make a difference, whether the incoming object is a friend or foe. Everything is to be a human intervention. Now with the artificial intelligence, we are able to carry out distinct discrimination between the targets, and also even the decision making also. But again, artificial intelligence requires relatively much higher computational power. And how we are able to get the computational power with the miniaturized electronics, the smallest size, this is another challenge technically we need to do. Sensors are like eyes. If artificial intelligence is a brain, sensors are like our sensors, eyes and ears. Today, in the warfare, weapons are becoming autonomous. Autonomous means human will not have any control. Once you fire, you forget about the weapon. And the weapon has to be intelligent. It has to look for it. It has to hear, and then hear for the probably signatures, and act on its own and engage the target. For that one, the sensitivity of the sensors. Earlier, again, sensors used to be too big and used to draw heavy current. Now today, with the miniaturization, very small sensors which can develop much higher power are able to detect targets or signals from much farther distance. So the work on technologies on sensors is maturing, and as we move on, more and more technologies will come, and miniaturized and very effective sensors also will come in. The drives, earlier, as I said that earlier systems used to be mechanical systems. Then probably we got into era of hydro-pneumatic systems. Then probably we got into electro-hydraulic systems. Sorry, electro-pneumatic and the electro-hydraulic systems. And today you have electromechanical systems. For all these things, you need a drives. Drives means they draw very high current, and high current also requires that a drive that needs a power electronics. Today, this is one area where we still find a difference that we have power electronics, but to have them in a small size, this is another area which I think one can start looking at. Other source is power, the energy for these systems, defense technologies. The energy, different sources are available. But again, if something like missile, that can't have any much bigger thing. You need to have a energy source which is small but have a very high power density. Sometime back when we used to have silver oxide zinc, and now today we are moving towards lithium, and then as we move on, probably even better power sources with much high power density will be available. And other devices, RF. The communications, you all are aware how communications have changed this decade. Not only this decade, this century. In fact, not this century, previous century. So people said the previous century was dedicated to communications. So the communication is, whether it is the physical communication, is the digital communication, analog communication, we all are aware how communication is changing our life. You can imagine if communication is broken, how our life, day-to-day lives will be. Whether we'll be able to function normally, if the data stops flowing, and all other sensors become mute. So again, here the communication also, both digital and analog, the RF communication, where you need to have the powers, and then you need to have the emitters and then detectors. So this is another area which will play a very important role. Today we all talk about hypersonic. Initially, when we started flying, subsonic itself is a great achievement from where human used to fly. Then came supersonic thing. Now today people are talking about hypersonic. Anything that flies more than 5 Mach, and today people are talking about 10 Mach flights and 15 Mach flights. in such a high velocity with the effects of kinetic heating, need materials that can withstand such a high temperature because of a kinetic heating. And also the aerodynamic characteristics change. So another domain in defense where people are actively looking at development, where hypersonics will play a very, very important role in future. The propulsion technologies which have been there earlier also. But again, there are also a lot of advances in propulsion technologies. Earlier, the specific impulse of these technologies is improving. Earlier, we used to have a subsonic propulsion. Now, later the ramjet propulsion came. Now, today we are talking about a scramjet propulsion, so that the hypersonic weapons can be propelled using the propulsion. And also there are even pulse detonation engine and then rotary detonation engines which are having a very, very high specific impulse. And structures, of course, earlier we had a primitive structures. Now we have smart structures. Some of them will having a self-healing characteristics. Even if in a part of structure is there, the structure itself, will get itself realigned, and so that mission doesn't fail. Then material technology also has undergone a great change. And as you said, that hypersonic technologies and then even the scramjet related technologies are coming. You all are aware that everywhere nowadays discussion is about the aero engine. Like there's a very active discussion about aero engine. The one of the complex thing about aero engine is the materials that can withstand very, very high temperature. So this area where material science can provide good opening for many of the students to work on the futuristic things. And the coatings for these materials, if the material gets exposed to high temperature flames or or environment, then the survival of these structures. So the coatings also become very, very important things. And today we still have a challenge that for some of our futuristic projects, we still are looking for some of the coatings and materials so that we get the desired output. And another visible change what we are seeing is unmanned systems taking place in place of manned systems. Today we are talking about drones, which are you are seeing the ongoing warfare. Everywhere we discuss about drone. Basically, drones are unmanned systems. We are only talking about drone, but there are unmanned even sea vehicles also. There are unmanned underwater vehicles also. And we are also talking about a concept of manned-unmanned teaming. So that one manned system can simultaneously manage many unmanned systems. So this is a new concept and the technology which is coming up in the unmanned systems. As we move on, future we'll find that more and more unmanned systems and then robotic systems coming into the play. Recently, I read an article. I think one of the country, if I'm not wrong, with China or some other country, has mounted a gun on a robot. And they conducted a field trials also. So the days are not far that the robots with weapons will start getting into the battlefield. You can imagine the consequences if the robots come into the field, and then how is going to change the dimensions of the warfare. And other important point what we are finding here is manufacturability of the weapons. Today we read in newspapers that probably inventories of even the big countries are getting over. Like Russia has been fighting the war with Ukraine for almost 3 years. And there is a huge requirement of weapons. Whatever weapons the countries had, even the same thing is happening to US also. We are reading in articles that some of the big missiles like THAAD and Patriot, the numbers are getting depleted, and then manufacturing or replenishing these numbers is going to take a lot of time. So everyone is struggling, how do we make up the numbers? So earlier the concept was the weapon numbers used to be limited. So manufacturing used to be typical integration of the systems in a limited numbers. Today, if we have to manufacture in thousands or 10,000, tens of thousands, or some of the lighter weapons in lakhs, how are you going to manufacture? How are you going to have a production system? And are these weapons manufacturable? What I mean by manufacturability is how easily you can manufacture. One is that, okay, everything you can machine and then personally assemble every component by component, but it's going to take a lot of time. How we can produce many more weapons in the shortest possible time. That's what is called manufacturability. And then, of course, integration and testing and all those things. So these are the areas where, world is changing. And many new technologies are coming. Many avenues are coming in space-related technologies. Many avenues are coming in artificial intelligence, using artificial intelligence, and we are seeing that, starting from surveillance from space and then giving decisions based on this data and passing information on to the soldier who's in the front. It has become a reality and being followed day to day. So in this change of environment, how are we going to position ourselves? Like, I think as a future generations who are going to work on these technologies, some of you are definitely going to work on these defense technologies. In which area are going to contribute? And how the technologies are going to shape up in the coming future. So this all, we have to wait and see. But I can tell one thing that, it is an emerging area. Things are changing very fast, and we also need to change along with this contemporary technologies. And we had a similar challenge. I think in 2019 we had, since you talked about mission Shakti, I thought I'll talk about it. That is a challenge which was given, and we have to have this mission in 2 years' time. Then one of the challenge was, like, why I'm bringing this example is, one is that, if there is a requirement, and if you have to meet an objective, one is look for the best technology and then start building on the technology, for probably a number of years to make technology. And other option is, how do you harness the existing technologies and meet the objective? Like, if you actually, you have to meet the object in the shortest possible time and you don't have time, you can meet the objective by using existing technologies also, but through innovative processes. Like that way, we had many examples in India, through which we use existing technologies and achieved the goal which seemed to be impossible those days. Mission Shakti is one of them. And now you are seeing, almost every month a lot of articles are coming out, indigenous systems. And with these systems, we are very actively working, and we are trying to catch up with the latest technologies. And many areas we almost become contemporary, and it is you all who have to take it to the next level. And I thought I'll give you just this broad overview about the defense technologies. But one thing, what I talked about is basically the weapons based technologies. But the subsystem level technologies, it needs much more focus, and then the detailed research for a long time. For example, whatever sensors I said, like there are sensors which we are using, but there are futuristic sensors which are even smaller and which are even more highly sensitive also. But for the technology, you need to start working, you need to invest your time, you need to invest the resources and start working now itself. The maturity of the technologies may not come immediately, but over a period of time will gain. For that one, we need to have infrastructure, we need to have laboratories, we need to have a right manpower working on this one. And then only we become, we can say that, a global leader. We become a global leader when we innovate and relay systems first time in the world. There are many systems which you are working on, and I'm sure you all will make the difference. Otherwise, what happens is, if you are working on systems which already realize, you are only following the trend. You'll be able to break the trend and become a leader if you invest our resources in the futuristic technologies and realize the first of its kind projects, the products which no one has realized, the products which no one has envisaged or thought about it. So that's where the difference will come. And in defense technologies, such a difference will be a very big boon for the country. And I hope you all will work in this direction. And I wish many of you take up defense as your career for future, and work on these technologies, and then bring in a lot of innovation and many innovative products. Thank you, KIYE, for giving me this opportunity. In case anyone has some generic questions, I can answer. Specific questions, depending on the classification, I may not, but I am open for generic questions. Thank you.
Thank you, sir. It was such an inspiring session. We will now begin the interactive question and answer sessions. Participants are requested to post their questions in the chat box. Please keep your questions short, clear, and relevant to today's topic. Sir, we have an interesting question. What inspired you to join the Indian Air Force in 1988 and ISRO in 1995? What was that journey like?
See, as a child, we always used to be fascinated by aircraft and airborne objects. I'm sure every one of you, as a child, would be looking up in the sky, saying how the aircraft flies, and then we always have that attraction. So basically, that drew me to Air Force, and then after that, not ISRO, I joined DRDO in 1995, and I started working on the missiles.
Thank you, sir. We have another interesting question from one of our participants. As an IIT Kharagpur alumnus, what advice you would give to engineering students who dream of working in defense research?
See, defense is an area which gives you exposure to many technologies, and it will be very interesting also. And through defense, you will be contributing to the national security also. So if you talk about personal satisfaction, working on a contemporary technologies and contributing to the defense of the nation, I think that will be very satisfying for every individual. So start working on these technologies, and there is no end to development of defense technologies. As you work more and more, you will find more and more challenging assignments, and you get pleasure of working on these technologies.
So, with your permission, the next question.
Please.
What are the key qualities of DRDO looks for in young scientists and engineers?
We look for engineers with commitment to work toward development of technologies, and innovative and hardworking. Of course, the mandatory requirement is good know-how about the engineering disciplines. That is the underlining part. Only those can come to DRDO.
The next question, sir. What are the biggest gaps you see between academic research and what are the armed forces actually need?
Is a good and interesting question. The academic research focuses on development of concepts, or probably theoretical development of engineering or technology. So most of the time, the academic research ends with the publication of papers, and probably getting a doctorate. But what armed forces require are the systems, physical systems. Today, the gap we have is converting these theoretical studies into a products. So that's where we find the major difference between academic research and then what armed forces need. The concepts are ideas are there. Convert these ideas or concepts or theory into prototype and then product. That is the key. That's where I think we are lacking.
Sir, we have an interesting question from one of our coordinators, sir. Sahasra, over to you.
Good evening, sir. I am a fourth year student. My name is Saharsha. Sir, if you had unlimited resources for one defense research project, what problem would you choose to solve?
See, Sahasra, unlimited resources. I really don't know what we mean by resources. Are we talking about resources in terms of technology, resources in terms of human resources, or financial resources?
Technology, sir.
Technology. See, as I talked about the new dimensions of warfare, that is, one is in the space domain and second is in the hypersonic domain. These are the two dimensions where, of course, AI and all that. See, why I ask this question is, any product I take, it is a combination of a number of technologies. So it's very difficult to say that I'll have only one. But I think if you ask me, I think these are the two areas where we should start working on. Because when I talk about space, space has everything, starting from communication, starting from propulsion technologies, structures, vehicles, and then people are talking about weaponization of space also. And same with the challenges of hypersonics and then all the propulsion related technologies.
Thank you, sir.
Yes, sir. The next question is, how has the role of private sector changed in defense manufacturing over the last 10 years?
So it has changed a lot because around 2 decades back, the most of the even prototyping and manufacturing was done by our labs. Probably, I think it started somewhere in 15, 20 years back, the private sector started making subsystems. They were manufacturing subsystems which are designed by us. I think past 10 years or so, they are only designing and they are only manufacturing subsystems. And the past 3-4 years, we are finding that even they are able to make systems also, full systems also themselves. That way, private sector has grown significantly in the area of defense, and we'll see the traction continuing in future also.
Okay. Sir, what are the technologies should India prioritize to reduce import dependence in next 5 years?
See, actually, if you see the imported weapons, most of the technologies are available in India. But what we need to work on, like today, any of the weapons that are imported, okay, barring probably big platforms, like like aircraft. Also, we have our own aircraft. We have Tejas available. Probably Aero Engine is the one which we are importing. There are few. Some of the subsystems are probably some high sensitive sensors we are importing. But most of the weapons, we already have our similar class of weapons which are being realized in India. But only thing is, okay, the numbers are more, numbers are not more, and production has not picked up because the industry don't have confirmed orders. But take any weapon, the India, either government or even private sector is also coming up. We are able to realize the weapons which are imported. But your question, I'll take it on. But our role is not to just replace the imported weapons. We have to start looking for future. If you have to remain a leader in defense technologies, we have to invest in these technologies. Like as I said, that miniaturization, relation of design and development of the miniaturized sensors. Then, as I said, hypersonics, space technologies, and then avionics, and then miniaturized avian. These are the areas where we should start looking at. And then DEW, like direct energy weapons. This is another domain which is very, very active today. If today DEW have become very active, be it be lasers or EM weapons. This is another area where we should start working on.
Sir, we have another interesting question from one of our participants. How do we build a culture of risk-taking and innovation in India, the Indian defense R&D?
No, I think it's a very important point. This which everyone has realized. See, the fear of failure draws back many people from taking a proactive measures, proactive steps. Because still, failure used to be a taboo until some years back, but now the culture is changing. Because failures will come only when one attempts. And if you are looking for innovation, in fact, I was reading some article which says that 90% of startups, they don't survive beyond a certain time. Only 10% survives, and all those 10% will become probably unicorns and much, much bigger. See, but if everyone thinks that 90% will fail, they don't take initiative, the 10% will not come. So we have to come out this fear of failure. But I think things are changing. And in R&D, there will be failures. Failure is a part of the process. And without failure, no successful product will come out. So we have to overcome the failures. We have to learn from the failures. We have to understand the failures and take corrective measures. And I think slowly this mindset is sinking in everyone. And today failures are no longer a taboo. And people are encouraging people to take innovative ideas and take them forward. And if it clicks in a great success, otherwise it's fine, At least we learn from these failures. That I think that is the present philosophy.
Sir, can you share how a student can approach a DRDO scientist for membership or guidance?
See, today DRDO has started many schemes. You all are aware of internships. In fact, earlier internships used to be, someone has to request, find, and then. Today, I think every laboratory is giving advertisement for paid internships. Student get paid, I think, some 5,000 rupees or something for the internship. It is a proactive measure, and please keep looking for the advertisements on the website of DRDO, through which the paid internships can be taken. But otherwise, many projects of DRDO are given to academic institutes. So the professors will be able to guide the students also. And DRDO welcomes the students to their laboratories and all. That way, interaction wise, many laboratories have these interactive sessions. So students can get in touch with the scientists and then probably talk to them and then work on those areas.
What mistakes do you see in bright students make when trying to enter defense research?
No, we don't see. If you talk about mistakes, we can't say mistakes at the early stage of the career. The mistake will be something like self-inflicted mistakes, saying that not paying much attention. One is when any student joins organization, the main idea is to learn. The learning comes in the first initial stages where the environment is open. No one will have any inhibitions to approach anyone and then clarify. The only mistake one student does is not getting the doubts or or the queries clarified, for the fear of being rejected or because of whatever inhibitions. So that is, if you ask me, I think that is the biggest mistake any youngster can do. If you have a doubt, please clarify, and everyone will be very happy to clarify. If you don't clarify today, after 10 years, you yourself will will be very hesitant to ask the same doubt, and people will laugh it also. This everything you don't know. So I think that is one, in my opinion, that's the biggest mistake. And second, other things are there, commitment, all those things are applicable for everyone. If you have a query, if you have a doubt, please clarify at the earliest opportune time, and earlier the better.
Sir, the next question. How do you handle pressure when a mission has the entire nation watching?
I think, it is incorrect to say that, we don't have pressure. We do have a lot of pressure, but over a period of time, we develop the sustenance to absorb that pressure. See, with every mission, our sustenance level goes up. First mission, where a smallest mission itself, we are highly tensed and then we are worried and all. But when you come to the next mission, up to that level, your threshold is already reset. Like with the number of missions, our threshold gets reset higher and higher, and our capacity to absorb also becomes more. But even today, we have pressures when we have important national missions.
So we'll move to the next question. What's your take on autonomous systems and robotics on the battlefield?
These are the emerging areas. A lot of progress is being done, and these will be future weapons, and we will see them getting inducted more and more in numbers, and warfare also changing in the coming years.
So we have an interesting question from one of our coordinator. How do you see collaboration between DRDO, ISRO, academics, and startups shaping India's future?
It is going to happen. The DRDO already has opened institutes called Center of Excellences. DRDO Industry and Academia Center of Excellences in 15 major academic institutes. The role of these centers are to collaborate between, to bring in collaboration between industry, DRDO, and academia. And this is happening. And ISRO also technically, we though through different organizations because we work in the same technical areas. So wherever we have for our external reviews, we do have ISRO with us.
Sir, if you weren't a scientist, what profession you would choose?
Difficult. In fact, as you introduced me, I started my career in Air Force and later become a scientist. So I think two paths of career are good enough for an individual to probably think and start with.
Sir, could you explain in simple terms how India's ballistic missile defense system works and why it's important for national security?
I will not talk about India's specific systems because of the security restrictions, but generally for any country, if the country has to defend herself from ballistic missiles, you need a ballistic missile defense system. Basically, which requires the intimation about the incoming missile, that is through sensors, whether radars or space-based sensors or IR sensors. Once the information comes to the command control center, you have to estimate the path of that incoming ballistic missile and activate our own interceptors. We know where all our interceptors are available and then their capabilities, and appropriate time launch interceptors so that we intercept the incoming ballistic missile. This is basically how the ballistic missile defense works.
Sir, the next question is, Mission Shakti made India the fourth country with ASAT capability. What were the biggest challenges during the mission?
There are many challenges. One is the timelines of the mission. It is a national mission, which has a very important, objective. And the second challenge is how to intercept object that is moving at almost close to 8 kilometers per second velocity. And if we talk about interceptor, and the interception has to happen at around 350 or 400 kilometers altitude. So we are talking about one object traveling at 8 kilometers per second, 400 kilometers away in the air. You have to launch one projectile from ground, which with whatever relative velocity, go and physically touch that object 400 kilometers in height and then traveling at that speed. This is a challenge. Because of the velocity of our interceptor also, the relative velocity was almost close to say 11.7 or 11.8 kilometers per second. So for every second there is a relative distance of 11.8 kilometers. So if you talk about if you have to physically hit object with that type of relative velocity and distances, what type of fine control do you need? That means in 1 second the relative displacement of 11.8 kilometers. So that means even every milliseconds or microseconds it is going to be in meters. A physical hit, when even the microseconds talk about that type of relative distance, that itself is the biggest challenge. And how do you have this mission in a short time with the existing technologies? That is a challenge for this.
Sir, we'll move to the next question.
Last two questions. I think my battery
Yes,
is
sir.
yeah.
How is India achieving self-reliance in missile guidance systems and technology?
See, we are seeing, last 2-3 months, you will see, in fact, someone can just go through the newspapers from probably end April or May, June. India would have tested more than 15-20 different types of missiles. And all of them are indigenous missiles. So what is self-reliance? We are able to make our own missiles and successfully test them. Then comes in making numbers. So our true self-reliance comes when these missiles get produced by Indian industry in the required numbers. So I think that's what is going to happen. So we are in the right way of self-reliance. In fact, in the starting also somewhere in my statement I said that we don't need any technologies for making imported weapons. We look technologies for futuristic weapons. We can make whatever weapons are being imported. Similar weapons we can make very well in India. But what we need to work is the future technologies in which weapons will be made.
Sir, who has been your biggest inspiration in your scientific journey?
There are many more. Many scientists were there. Okay.
Sir, one last question, sir. If you would if you could give only three pieces of advice to every scientist and upcoming advisor on this call today, what would they be?
Innovate. Don't worry about outcome of your research or scientific work, and be well connected in the sense that you need to upgrade your knowledge to the ongoing changes. These are three advices I would like to give.
Thank you so much, sir, for such a detailed explanation and patiently answering all the questions. Now, I would like to invite our coordinator, Ms. Soumya, to deliver the vote of thanks. Soumya, the virtual stage is all yours.
Thank you. Thank you.
Thank you, Mohit. Thank you, Mohita. Good evening, everyone. I am Soumya, one of the student coordinator at Kalam's Institute of Youth Excellence. It is my great privilege and honor to deliver the vote of thanks for today's inspiring S-Talks Lecture 18. First and foremost, I would like to express our sincere gratitude to our esteemed speaker, Dr. Ummalaneni Raja Babu Garu, for gracing us with your presence and delivering such an insightful session on insights on India's defense technology, missile systems, and innovation. Sir, your lecture gave us a deeper understanding of India's remarkable achievements in defense technology, the evolution of missile systems, the success of Mission Shakti, and the importance of innovation and self-reliance in strengthening our nation. More importantly, your experiences and words of wisdom have inspired us to dream bigger, think scientifically, and contribute meaningfully to our country's future. Thank you, sir, for patiently answering our questions and encouraging every student to develop curiosity, confidence, and a scientific mindset. Your guidance has motivated us to believe that today's learners can become tomorrow's innovators and nation builders. I would also like to express my heartfelt gratitude to our respected mentors, the KIYE Foundation team, and the organizing committee for the constant guidance, encouragement, and dedicated efforts in making today's session a grand success. My sincere thanks also goes to all the dignitaries, guests, students, and everyone who joined us through the live session. Your enthusiastic participation and active interaction made this event truly meaningful and memorable. Once again, on behalf of Kalam's Institute of Youth Excellence, I extend a heartfelt gratitude to Dr. Ummalaneni Raja Babu Garu for sharing your valuable time, knowledge, and inspiring vision with us. We are truly honored to learn from a scientist who has made significant contributions to India's defense and aerospace capabilities. Thank you all for being a part of this wonderful session. Let us continue to learn, innovate, and contribute towards building a stronger, safer, and self-reliant India. Thank you, Jai.
Thank you, Soumya.
Thank you, Soumya.
Thank you for having me.
Thank you, Soumya. As we conclude today's S-Talk Lecture 18, let us remember that science, research, and innovation are the strongest pillars of nation's progress. On behalf of KIYE Foundation, a heartfelt thank you to our respected speaker, Dr. Shri Ummalaneni Raja Babu Garu, for sharing his valuable knowledge, time, and experiences with us. We extend our heartfelt gratitude to Dr. Shri Ummalaneni Raja Babu Garu, not only for today's enlightening session, but also for your constant encouragement, guidance, and unwavering support towards KIYE Foundation. Your mentorship continues to inspire young minds. We look forward to your continued support and blessings in our future activities. To all the participants, always work towards building a stronger and self-relevant India. That brings us to the end of today's S-Talks Lecture 18. Before we sign off, do stay connected with KIYE Foundation by following us on WhatsApp, Instagram, YouTube, and LinkedIn for more exciting sessions and opportunities. Thank you everyone for joining us today. Have a wonderful evening.